Hi, everybody. Welcome back. And today, this will be our second lecture note. And we're going to talk about section 7.3, Introduction to the Probability. So we finished chapter 5 about the interest, annuity, those things. So right now, we are going to jump to a different topics. We're going to talk about the probabilities here and a little bit about the statistics. So before we start, for the probabilities here, and for this sections, we have a few things we want to talk about. So the first thing is here, we're going to learn a couple definition. So we're going to learn what is the sample space. Okay, then we also, so this is the first definition we're going to learn. Then we're also going to learn what we call this the event. And then the third one here, we're going to talk about is the events, operations. Okay, so when we talk about the first things here, when we talk about the sample space, what do we mean, the sample space here? So the sample space, the definition is the collections of all possible outcomes from an experiment. And usually we use capital letter S to represent the sample space. Okay, so that's what our definition about the sample space is here. The key word here is all the possible outcomes. All right. So let's take a look and what I mean here. So the first is here. Okay. So let's take a look at this one. The examples here. So let's say is from the experiment. So I can have so like here, let's say, okay, my experiment is here. The first one here, I say I toss a coin. So we know when you toss a coin, you will get either the head or tails, right? So that's how my sample space here will just be what you can say is head or tail, correct? So you use a brace. So this is the braces to represent sample spaces here. Okay, so now let's take a look at the second one here. So this is the number one here. So I say I toss a coin. Okay, now let's take a look at my second experiment. I say I toss a die. I know a die has 6 faces, right? So when you toss a die, you could come up with 1, 2, 3, 4, 5. So now my sample space here will just be what? Will just be 1, 2, 3, 4, 5, 6. That's what we say is all the possible outcomes, right? So you list all the possible outcomes. Okay, let's get a little bit more, a little complicated here. So how about I say, instead of the 1 coins, I said, hey, right now I'm tossed 2 coins. So for the 2 coins, so each one can be head and the tails, right? So first coin can be head and the tail, the second coin can be head and the tail. Then that means my sample space, I'm going to have a paired data, right? So that means these ones here, I can have a head, correct? That means the first coin is a head, second coin is a head. Then I can have a head tail, right? So that means my first coin is a head and the second coin is a tail. Then I can have a tail head. That means my first one is a tail, the second one is a head. Then I can have a what? I can have a tail, right? So that is all the possible outcomes. So the first ones here, that means this is the first coin. And then the second indices here. So the second one's here, this is that means the second coin, right? So that's why total I have 4 elements. And each element is kind of like a pair, is the first and the second coins, right? Okay, so now let's take a look at number 4 here, right? So number 4 here. So now if I want to pick up a marble, okay, from a container with red, yellow, green, and a blue marble. All right. So right now I said, okay, I want to pick up a marble, and this container has 4 different type of the marble: red, yellow, green, and the blue. Then I know my sample space is here when you pick up the one marble. So your sample space, you could be, you get a red one, you get a yellow one, you get a green one, or you get a blue one. So that's what we call is the sample space, right? So the keyword here, don't forget, is this all. That means it's all the possible outcomes, when you do an experiment, all right? So now we're going to talk about event. Okay, so let me go to the next pages here. So here is event. So what is event here? Okay, so we say an event is a subset. Is a subset of the sample space. Based on certain specific criteria. Okay, then we typical, right? We use the capital letter like a, you can use like A, B, C, to represent events. Okay, so that's what the events mean. Events is like so the keyword here we need to be careful is like, that means based on your sample space is a subset. And how do I define this subset? It depends on the specific criteria. You can define whatever the criteria you want and get events here. Okay, so now let's take a look at the examples here, what I mean, right? Okay, so let's take a look at these examples here. So okay, so now my experiment is I toss a die. Okay, then I define the event A is it gets an even number. Okay, so for this experiment, okay, so from the previous page, I know if I toss a die, the sample space here, right? So it will be 1, 2, 3, 4, 5, 6. Then the event A, remember we use a capital letter to represent the event A. A say, hey, I'm getting an even number. So the A's here will just be a subset of your sample space. So even number will be 2, 4, and 6, right? That's pretty simple. Okay, so now let's take a look at another examples here. I will say the event B is get at least the event B get at least 5 or larger. That means that I'm looking for my sample spaces here. So you have event B's here. The B says is that at least you get 5 or larger on your experiment. So I know I look here, so at least 5 over 6, so it's 5 and 6. So this will be my event B's here, right? So it's pretty straightforward. It depends on what you defined. So like in here, I defined it to be even. Then I look back to my sample space to see, oh, okay, those are the even. And then the second one here is a 5 or larger. So you look back to your sample space to see, hey, which one is 5 and the larger here. Okay, so now let's take a look at another examples here. So the another examples here is, let's try to take a look. This is number 3 example. So I'm going to toss 2 coins. Okay, then I define the event C is gets no head. Okay, so now for this experiment in events here, I say, okay, toss 2 coins. So my sample space here will just be what? My sample space, like we did from the previous page, will be head, 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 tail, tail, head, tail, tail, right? Okay, now now the event C, let's say, hey, this is my specific criteria, say no head. So that means in here, I know my C will be equal to the no head. That means I cannot have a head head, I cannot have a head tail, I cannot have a tail head. So the only elements is in here is a tail tail, because they said no head here. Okay, that's what we call the events here. All right, so it's pretty simple, right? So the sample space and the event is just a possible correction of the outcomes. Sample space is all the outcome. Events here is depend on how do you define these events. Okay, so the next topic we want to talk about is the event operations here. Okay, so here, so this will be the events operation. So this events operation is very similar, like just like if you have a real number, you want to add, subtract, divide these things here. So the events operations here, we have 3 kinds, right? So the first one we call is the intersection. Okay, so when you see the intersections here, the keyword in the province lane, so you know is the intersections, right? And the keyword here, you most likely you will say is end. So the intersections really is just what we means is the end, right? So like A and B, that means A intersect B. And the notation we used, so the notation you will see the intersection is this notation. It's an upside down U's, okay? And then the next operations we're going to talk about is union. All right, so union, that means you combined these two together here, right? So in the problem, in the work problem, the keyword you will see is what we call is or. That means A or B, right? And then the notations here you will see is like the way we use that to represent the union is we typically use like a kind of just U, the capital letter U here. Okay, so then the next things we're going to see the operation, we call it a complement. Okay, the complement. So what is the complement mean? So the keyword you will try to see here, it will be not. That means not A or not B. And the notation you will see here, oh, I'm run out of the space. Okay, so the notation you will see here, typical you will see a prime, or some book use like a C to that. Okay, so let's try to write it. So this one's here. Okay, so intersection, so basically we say is A intersect B. That's what is the notations we have. Union, like for example, we say A union B. So the complement, that means it's not A or not B. So we say the A prime. So sometimes some book use A complement. Either way will work, right? So that's what is the, okay, so that's what the things. Okay, so now those are the few operations here. So I can represent this operation. I can use graph. And this graph, we can say, we call this the Venn diagram. It's pretty easy to understand the concept. So what is the Venn diagrams, right? So the Venn diagram, that means in here, first you draw a rectangle. So the whole rectangle, you call this is the sample space. So everything in there is the sample space here. So now for the intersection, A intersect B, we represent the events with a circle, right? So if this is your event A, this is your event B. Then when we talk about, when we talk about the intersection, we say and. That means the common part, right? So this area is what we call is the A intersect B, okay? So now let's take a look at what is the Venn diagram for the unions here. So still, you put everything, the rectangle is your sample spaces, right? Then you have two events. This is A, this is B, right? So this is A, this is B. So what is the A union B means? The A union B, that means you combined these two. So this will be, so this area is, we call this A union B, right? And then now, the next thing here is complement. Let's take a look at what is the complement mean. So we say it's not, right? Okay, so still, this is your sample space. And this is your event. Okay, I call it this is event A. So what is A prime? That means everything not in the, right? Not in the A. So this is what I mean. The A prime. Okay, so that's why we say that this is, you can use the Venn diagram to represent, to represent it. All right. So now You know, so sometimes the graph, if you use a Venn diagram, is a little easier to see. So now let's start with some simple examples here. And show you what we mean here, right? Okay. Okay, so now, I have the same examples here. I like to use this one, toss a die. Okay, and then my event A is even number. And event B is so it's get at least 3. Okay, so now I'm going to find A union B and A intersect B. All right. So now let's take a look here. Okay? So let's write down what is the event A. So let's let me see here. Let's do this first. So let's write down the sample space first. So this we have been using this sample space for so many times. I think we should be quite familiar with it right now. That's right. Okay, so now let's write down the events. So the A is even number. So what is the even number? So it's 2, 4, and 6. Correct. Then the B, let's say, is at least 3. So this is 3, 4, 5, 6, right? So at least 3, that means 3 and above. Okay, so now let's take a look. A intersect B. That means the common area, right? So the common part. So what is the common part of A and B? So what is the common part here? Oh, I see the 4 and the 6, they both have a 4 and the 6, right? So that's what is the intersection, is the common part. This is 4 and 6. Correct? Okay, now the A union B is here. That means you combined these two together. So you combine this is 2, 4, 6. This is A. Okay, then you know the 4 and the 6 is the common part. So you don't need to rewrite it again. So the only things the B is different is 3 and 5. So you just need to include the 3 and the 5 here. So that's what we call is the unions here. All right. So now if I want to say what is the A primes here, the A prime is everything not in A. So the A prime will be 1, 3, and 5. Correct? Okay, so now let's take a look at the most interesting one. How about if I say A union B prime? What does A union B prime mean? That means everything not in the A union B. So what is the numbers here? It's 1. Right? That's why we base on the, what we have here. Okay, now let's take a look at how can I put this into a Venn diagram, okay? So just like we say, the Venn diagram, so here, this is my A, so this is my B, all right? So this is A, this is B, and this is my sample space here. Okay, so let's take a look, all right? So the first things we know, the first things we know, A intersect B is 4, 6. So 4 and 6 is going to be in here, 4, 6, right? And then let's try to fill this part here. This part is 2, right? So the A is 2, 4, and 6, but the 4 and 6 belong to here, so 2 is here. Then look at the B. B is 3, 4, 5, 6. 4 and 6 is here. So outside this here will be 3 and 5. Then we see the total should be 1, 2, 3, 4, 5, 6. We have 2, 4, 3. So the outside 1 is outside. That is what I called is the, the Venn diagram to represent the, the loss operation. Right? It's pretty cool, right? Okay, so now let's take a look. I want to show one more example before I end this video. So this is example number 3. Okay, so this is example number 3, all right? So I want to see is draw a car from the 52 card deck. And if you're not familiar with the car, maybe you want to take a look what is the car about, right? So we know a 52 deck, we have a spade, right? So for the cards here, we have 4 suits, right? So we have a spade, and we have a spade, diamond. Both these 2 suits are black. And then we also have a heart, spade. Oh, I'm sorry here. The diamond is red. Diamond is red here. Okay, so diamond is red. Okay, so diamond. And then here, the black one is club. Okay, so this is club. All right, so we have 2 red and 2 spades, okay? Okay, so now I want to find the probability. Let's see here. Okay, part A is here. I'm going to draw an ace here. Okay, so I know every time I draw cards, right? So my event A is an ace. Draw an S here. So I have how many elements here? I have 4 different kind of aces here, right? I have a spade, club, so and a heart and the diamonds, right? So for the ace here, I have 4 elements here, correct? So for each suit, I have an ace. So I have 4 aces here. Now I know if I draw 1 card from the 52, every card I have an equal chance to get it. So I have a total 52 chances here. So the probability of getting an ace here, it will be what? It's 4 out of the 52, correct? Or you can simplify it to the 1 over 13. That means I'm only, because of aces here, I have 4 aces. Each suit have aces here. Okay, so now let's take a look here. Let's take a look at draw, if I say a face card, okay? So I will let my event B is a face card. So let's take a look. The face card, that means the king, queen, and the jack. So we have 4 face card in each suit. So we have 4 face card in the spade, 4 face card in club, 4 face card in heart, and 4 face card in diamond. So total, how many elements? Right, we have 4 times 3. So we have a total 12 elements in the events. What? In the events B here, right? So we have a total 12 cards I can draw is a face card. So that's why my probability of a face card is what? It will be 12 over what? 12 over 52. Right, so if you want to simplify it, it will be 3 over 13. All right, okay, so now, see here, next one here, I'm going to draw a spade. Okay, so let's say the event C is a spade. So I know each card, so like for each one here, they have a 13, right? So total, that's why they get up to the 52s here, right? So they have 13 cards for each suit here, right? Okay, so that's why. All right, so the draw a spade. So I know how many cards in here. So the spade total, how many elements? 13 elements. I have a 13 cards here. So that's why the probability you're going to get a spade is equal to what? It's 13 out of the what? 52, so it's 1/2. It's pretty cool, right? Okay. And then the next ones here, the last 6 ones here. And so let's see here. This ones here is draw a spade or heart. Okay, so let's, the D is a spade or heart. Remember from the previous, we say, as soon as you see this word or, that means you combined. So the spade, I'm combining the spade and the heart. I know each suit, I have certain elements. So right now when I combine the spade and the heart, total how many elements I'm having? So I'm going to have what? 26 elements. Right? Because you combine, because we say the or is the key word for combining these two, or the union, these two sets. So it's 26 elements. So the probability I'm going to get a spade or heart, it will be what? It's 26 or 52, so it's 1/2. All right, so that's pretty cool, right? So like a lot of time when we play the card, when the people talk about the counting the card, so if you know a little bit of probability, so probably, I don't know, will increase your chance to win a little bit more in the casino or not, but certainly will not hurt, right? All right, so I'm glad we finished these sections. This is section 7.3, and it is the introduction of the probability. So in the next sections, we're going to talk about some probability rules. We'll talk about the addition rules and the multiplication rules. It's also is pretty fun. So so after you finish reviewing this video, make sure you finish the classwork also, right? So like we did before, every time when you finish the video and just like we finished the lecture in the class, and go ahead and try to practice your classwork, and then that might help you try to do your math lab homework. Well, okay, so that's it, and have a good day. And if you have any questions, don't hesitate to send me an email, all right? And I think I will talk to you for our next lecture series. Okay, goodbye.